Hi my friends, take a look at this model and observe that this is an arrow, a blue arrow with the same length always, and this is a red arrow with different lengths, as you can see in the graph. The blue graph is constant and the red one is oscillating. They show the velocities. You see here the physical mechanism from my Toyota Corolla 2004. It is used as the one connected with the steering wheel of the car. This is the steering column assembly of the car, for your information. In order to verify the functionality of this model, I made the assembly. As you can see, we can rotate the motor end to see what happens to the output end of this mechanism. All the components can be downloaded by you. They are made in 2015, so that you can use your actual version of the Inventor to model it. To download, please take a look at the last row in the description of every tutorial. We start by using that components, I repeat, made with Inventor 2015, to create the first component here, which is a subassembly. This is that subassembly, yes? We'll continue with using the other components to create a stand. We start with placing this fork as the first component, because this is the input movement, this is the output movement, and I want to create this from right to the left. New standard millimeters IAM, place short fork somewhere in space. Now I use free rotate to place it in that position as possible as I can. For instance, so I make it grounded for the moment. Then I place the universal joint cross, escape, constrain this axis to this axis, apply, then coincident or align the end here. Okay, I rotate this cross, I make it also grounded, then place the next, which is a long fork right here, constrain this axis with the horizontal axis, as you can see, but reverted, aligned. I want to see this face. apply, and then also align these two. Okay, we go on with placing the medium fork, this one. I also rotate it to be somehow in this position. Constrain axis, this axis with this axis, apply angle. First solution of this face with this face, apply. Then I move this along the axis and I apply aligned this face with this face. Apply. Cancel. Then grounded this for a moment. Place another joint cross here. Escape. Constrain this axis with this axis. Apply. Align this end with this face. Okay. Now I rotate the cross as you see here. Again grounded. You can separate which are grounded and which are not grounded. Now all of them are grounded. Good. Then I place the other short fork here. I apply constraint of this axis to this axis, apply and align between these two. Okay. Now I can add, this is not grounded, yes? It must be somehow so. Now I place the two grooved shaft. One is here, another here. Then constrain, insert this circle over this circle, apply. Now I want to rotate this to be like this, and I make them aligned in an angle of 0 between this axis and this face. Okay, apply. The other end with insert this over this, apply, and last constraint, angle, first solution, axis with this face to be with this face to be 0 degrees. Okay, now you see some of them are not grounded, the other are grounded. I apply not grounded for the components which appear to be grounded, having that pin, as you can see. Now there is no pin here, and we have that free to be moved. Yes, sub-assembly, as you can see. I save this sub-assembly under the name universal joint after, to be not confounded with the universal joint, which is here. We go now to creating the stand with this component. New, standard millimeters IM, place base plate somewhere and not grounded, because this was made with Inventor 2014, which you will download, yes, so that I cannot change parts here. Inventor 2014 had the Z-axis as a vertical, and now Inventor 2024 has Y as vertical axis, so that I must place it in the proper position. Constrain this face to be over this, apply. Then we place the center point of the part over center point of the system, apply. And the last, angle, first solution, this face with this plane to be 0 degrees. Okay, now we have a grounded part. I cannot move it with this axis as we want to have. Place bearing 1, 2. Constrain face to face, apply, and face to face, apply. Now we place the center point of one bearing on the XY plane, apply. Then the other bearing, its center point on XY plane, Okay, one is here, the other one is here. We apply angle, constrain. No, I want to place in position this constrain 145, 175. The center point of this bearing with this plane 175. Apply. The angle now is first solution between these two, 45. Apply. And the other one also angle, also first solution, but minus 45. No, 45. Okay. Now everything is fixed, but not this. Why? Because we have to place now the sub-assembly in order to obtain the expected assembly or mechanism. Place universal joint after. Then we make this flexible because we want to connect each component and components with our stand. Constrain, insert this circle to this circle, but the other direction. Apply. Then axis, this axis with this axis. Apply. Then contact between this face and this bearing, which is movable. Yes, now they are placed together and we have an assembly which is flexible. You see, we can rotate one or the other component to obtain a movement. Okay, now we have to apply dynamic simulation to be sure that this mechanism is special. If you rotate uniformly this input, you obtain a non-uniform movement or rotation at the other end. Environments, dynamic simulation, and we have all that constraints converted to joints automatically. If I activate this, nothing will happen because no gravity is applied and neither any other force or momentum. Look, nothing. Yes, go back and we select the joint from here, which is this is the joint from here. Yes, that first insert from here, revolution between welded group, which is this combined with this short fork with the grooved shaft. And what to do here? We double click this, we go to the only degrees of freedom, rotation, this is only movement here, then imposed motion to be enabled, velocity is our motion to be imposed, constant value, we intend to rotate constantly here, and we place here 60 degrees per second. Okay, click here and start again. You see, we have a movement of 1 second. In 6 seconds we cover a full circle, yes? 60 multiplied by 6. Go back. Construction. I want to rotate in the other direction. Double click here. I edit this and I apply minus 60 degrees. Okay. Then I place here 6, not 1. Rotate. Move. Go on. You see? You can make it to be speedy or not at your will. More than this, I want to make to disappear these vectors. Click here, simply click. And now I apply trace. Trace to this, to the center of this, but with the color of blue. Okay. I select this. Apply. And another trace, red, color red, okay, on this center. Okay. Now I apply movement and we see that traces are created. We don't see how is the variation, what is the variation of this rotation. So that we go to output grapher, we make it a little larger. I place this here, here, so I go to traces, trace 1, edit, edit and place velocity, okay. And now I activate V, the velocity, and you see this is constant. Yes? Good. The other trace, edit trace, velocity, okay. Velocity to be this vector. You see, the output is not constant. The red graph shows us that this is not a constant movement. Very nice, very interesting, and this is all I wanted to tell you now. That's all for today. Thanks for watching. Bye bye.